Students, in my latest of my special topics Lecture 1 videos, a systematic review of chapters 4 through 5, I'm going to here teach you more about molarity, or at least review it, and how to do some cool calculations involving it. Are you ready? Let's go ahead and get into it. So as you may or may not remember, molarity, abbreviated as an italicized capital letter M, is a way of expressing a solution's concentration. Simply put, molarity is moles of solute divided by volume of total solution in liters. So we could say then that molarity's units are moles per liter. Please make sure you don't forget that because it's important when you do dimensional analysis with it. So to do a molarity or concentration problem involving molarity, please make sure that you remember that molarity's units are moles per liter. Next, look at what information, especially which units you've been given. Next, determine what you're being asked to find, especially what units your final answer should have. And next, use dimensional analysis focusing on units to convert what you're given into what you're asked to get. In other words, use dimensional analysis to move from your starting point to your destination, focusing on units. Units! Enough said? Let's do an example. How many moles of HCl are present in 35 milliliters of 4.5 molar solution of hydrochloric acid? I'm not going to do this for you, but invite you to attempt it on your own, and if you like, you can click the link here to a separate video in which I will show you how to do it on the .cam or board. Here's another one. How many milliliters of 5.1 molar HCl solution are needed to obtain 0.1 moles of HCl? Once again, I'm not going to do these for you, but invite you to do them on your own, and then if you need help, click the link here to a separate video in which I'll show you how to do it on the .cam or board. Here's another one. How many grams of solute are present in 15 milliliters of 0.736 molar potassium dichromate? And separately, how many milliliters of 1.5 molar sodium phosphate contain 2.5 grams of sodium phosphate? As I've done before, I will not show you how to do these right here, but if you like, you can attempt them on your own and then click the link here to a separate video in which I'll show you how to do them on the .cam or board. Now, that takes us into a new subject, that of neutralization reactions. Now, just so you know, we can add acids to bases to have them neutralize each other. As we discussed earlier, or at least in a separate lecture, acid-base reactions are called neutralization reactions. To neutralize a strong base, we add the same number of moles of strong acid as there are moles of strong base to the solution. So when those moles equal each other, I have a completely neutralized solution. So most neutralization questions ask us to figure out how much acid must be added to neutralize a certain amount of base. To do these questions, first, figure out how many moles of hydroxide are present in the solution. Next, figure out what the volume of acid at the given molarity would be needed to provide the same number of moles of acid as there are moles of base. And that's pretty much it. Let's take a look at a problem then. What volume of this concentration of perchloric acid solution is needed to neutralize 50 milliliters of this concentration of sodium hydroxide? And separately, what volume of this concentration of HCl is needed to neutralize 2.87 grams of magnesium hydroxide? Now, in typical me fashion, I'm totally not going to show you how to do this here, but invite you to attempt to do it on your own. If you like, you can click the link here to a separate video in which I'll show you how to do it on the .cam or board. Now let's take a look at some more. This example says, what volume in milliliters of 0.135 molar NaOH is required to neutralize 13.7 milliliters of 0.129 molar HCl? Once again, I'm not going to do this for you, but we'll invite you to do it on your own. And next, what volume of this concentration of perchloric acid can be neutralized by using 115 milliliters of this concentration of sodium hydroxide? Isn't that cool? Good. Now that takes us to the end of this video. Please stay tuned to the next one in which I'll begin teaching you about specific heat and heat capacity. Until then, my wonderful students, have an enjoyable rest of your day.